Okay, I think I figured out my problems here. Okay, here's question 2. I know it says 1 right there, but that's the question number. The absolute minimum value of this function on the closed interval occurs where? Okay, now this time they're looking for an x. So what we need to do is find the derivative. So 6x squared plus 18x. When does that equal 0? Okay, well that happens when 6x, x plus 3 equals 0. So that means x equals 0, x equals negative 3. Okay, so we need to check the function value at these 2 points, but we also need to check the function value at the end points. Okay, so let's go ahead and plug in 0 and negative 3 to the function to see what we get. F of 0 is negative 10. F of 3 is equal to 2754 plus, let's see, negative 3. Negative 3 cubed is negative 27 times 2 is negative 54 plus 9 times 9 is 81 minus 10. So this is going to be, let's see, 81 minus 10 is 71 minus 54 looks like it is 17. Okay, so that's f of 3. Now we have to take a look at f of negative 5. Let's figure out where this is at the end point. Okay, I used my calculator to figure out the other two. I found out that f of negative 5 is equal to negative 35, and f of 2 is equal to 42. So which one of these is the minimum? It's going to be there. Where does it occur? At negative 5. So the answer is A, negative 5. Okay, question 3. Here we've got this graph. Okay, now what you could do, since I did tell you that you could use a calculator on this, you could just graph it and see what happens. But if you analyze it with calculus, what you get is the following. If we're trying to find out increasing and decreasing, what we need to look for is the derivative. 3x squared plus 12. Okay? Let's find a critical value first. When does that equal 0? Equals 0 when x squared is equal to 4, negative 4. Bring the 12, divide by 3. Okay? I don't believe that has a solution, does it? No, you can't take the square root of a negative number, so there are no zeros of f prime. So that means all you really need to do is just plug in a point, plug in an x value. What's f prime of 0? Well, f prime of 0 looks like is 12, which is greater than 0. So you see, f prime is always greater than 0. Since f prime is always greater than 0, then the function, I had a momentary brain fart there, sorry. So f prime is greater than 0, that means the function is always increasing. And if the function's always increasing, that means that the answer has to be A. Okay, my problem is I have my questions here on paper and I have the answers out here and the answer wasn't matching up, the answer letter, but the answer was. So apparently the answers are scrambled up too. Anyway, not a problem for you guys, it's just a problem for me. Okay, so question 4. Particle moves along the x-axis so that its position is given by this function. For what value of t is the particle at rest? If the particle's at rest, it means its velocity is equal to 0. So all we need to do is figure out when its velocity is equal to 0. So let's take the derivative, 4t minus 12. When does that equal 0? Well, that equals 0 when t is equal to 3. And so the answer to this is A. The answer is 3. Question 5 is easy. Graph below shows the velocity for the particle over the time interval from 0 to 6. At what time does the particle reach its maximum speed? The secret is right there. Its maximum speed is when the absolute value of velocity is the greatest. Okay, so the highest velocity is right here, but the highest speed is down here. and so the time is equal to 5. And so the answer to this is A. It's that right there. Be really careful about the difference between speed and velocity. Okay, question 6. Here's a graph. On the closed interval, how many points is the mean value theorem satisfied? Okay, remember the mean value theorem tells us that the slope of the line between the two endpoints, that's not a very good line, let's try that again. The slope of the line between the two endpoints is equal to the value of the derivative at some place in the same interval. So there's the tangent line. Where's the slope of the, or there's the secant line, I mean. Where's the slope of the tangent line the same? 1, 2, 3 different places. So the answer to this is 3. Okay, this one's a fun one. Okay, we've got this function and we need to find the values of c. Where on the x-axis is the mean value theorem satisfied? So what we need to do is figure out what the endpoints are. F of 0 is equal to 1. F of 3 is equal to 1 minus 3 cubed, which is negative 2 cubed, which is negative 8. So if we look at our graph, we're looking at something like this. This is the point 0, 1. This is the point 3. Got to go down here to negative 8. 3, negative 8. Okay? So our graph's going to do some sort of thing in between here. All we really care about is the slope of this line. The slope of the line is equal to negative 8 minus 1 over 3 minus 0. So that's going to be negative 9 over 3, which is negative 3. We need to figure out where on the function its derivative is equal to negative 3. So let's figure out f prime of x. That's going to be 3 times 1 minus x squared times negative 1. Remember the chain rule? We've got the outside function stuff cubed, the inside function the derivative of the stuff. When does that equal negative 3? Well, negative 3, 1 minus x squared equals negative 3. 1 minus x squared equals 1. So I guess that means that 1 minus x equals the square root of 1, which is equal to plus or minus 1. So I guess that means that 1 minus x can be 1, or 1 minus x can be negative 1. This one here is easy. That means x is 0. This one here means x is equal to 1. Or 2, I mean. So you might think that the answer to this is going to be up here at E, where c equals 0 and c equals 2. That would be incorrect. The problem, this one definitely will satisfy the mean value theorem. This one will not, because if you look in the book at the definition of the mean value theorem, it's on page 186, it says there has to be at least one point in the open interval a to b. Okay? The continuity condition is on the closed interval. So the problem here basically is that at this point right here when x equals 0, we don't know what happens to the other side of the function. If we don't know what happens over here, we don't know if this derivative actually exists. Okay, now this particular function, we know what happens over here, but we've restricted it to only being between 0 and 3. So it's like we can't even see the other side of the y-axis. And so that's why this won't be a solution of the mean value theorem. And the answer is going to be here at c equals 2 only.